Good morning, all of you. Once again, we are going to discuss about the hydrogen bonding. So, what is meant by the hydrogen bonding? So, it is the one of the type of bonding is there. So, there bond between hydrogen, the hydrogen, but that hydrogen should be attached with a heteroatom. Okay, so hydrogen attached with heteroatom and one more another heteroatom, there is temporary bonding is there. So hydrogen bonding is a special type of dipole attractions. Okay, so when the two poles are there, first upon here we are discussing, this is the example, this is the water molecule, this is the one another water molecule. Okay, so in this water molecule, accordingly inductive effect, this oxygen is electronegative with compare these hydrogens, and this all the bonding electrons shifted towards the oxygen side. Oxygen possesses del negative and this both the hydrogen possesses del positive. Same things here also, this oxygen possesses del negative and hydrogen possesses del positive. Now two poles between the two molecules. Okay, this is the positive poles, this is the negative poles. So this pole formation takes place and these two poles attraction is happens. So positive to negative attraction is happen. So at that time this bond is formed, so that bond is the hydrogen bond. Okay, so hydrogen bonding is a special type of dipole attraction between the molecule, not a covalent bond. It is not a covalent bond but is a hydrogen bond. Okay, it is not covalent, it is a result form attractive because at the same time this oxygen's lone pair stabilize these deficient hydrogens. Oxygen's molecules lone pair stabilize this deficient hydrogen, and this is the another type of bond formation takes place. So that bond is the hydrogen bond. This bond at the but one condition is there, this hydrogen should be bonded with any heteroatom. Okay, so more electronegative atom. Okay, so that could be nitrogen, oxygen, and fluorine. Okay, so specially should be, or sometimes it's chlorine also can show that same type of. Okay, so another very this hydrogen bond, it is result from the attractive force between the hydrogen atom and covalent bonded to very electronegative atoms such as oxygen, nitrogen, fluorine, and another very electronegative atoms. Okay, so that is the one more. So there is the given also. So hydrogen bonds are present in more electronegative heteroatoms which contains non-bonded electron. They should have a non-bonded electron means lone pair. They should be having a lone pair. Amines having lone pair, water having lone pair, this hydrogen fluorides, fluorine having a lone pairs. So that oxygen, nitrogen, and fluorine, they having a lone pairs, non-bonded electrons, and the same compounds another molecule is having a deficient protons, hydrogen. Okay, so that deficient hydrogen, del positive hydrogen, and a high energetic lone pair of that another molecule, they making the extra bond to stabilize that proton by the lone pair through the heteroatom. And these types of bond formation, this is the dipole interaction, one of the type you can say. So that types of bond is hydrogen bond. Okay, so the hydrogen bond and electrostatic force of attraction between the hydrogen atom attached to the more electronegative atoms. Here this hydrogen atoms attached to this more electronegative atom, this hydrogen attached to this more electronegative atom, this hydrogen attached to the more electronegative. So such hydrogens are the hydrogens, but condition what is that? That hydrogen should be attached with electronegative atom by the directly covalent bond. Okay, so that hydrogen and another heteroatom should be make a extra electrostatic attraction. So that is the hydrogen bond. And some other electronegative atoms for same or different molecule. It should be from the same molecule or from the different molecule. Here one more example is given. Here this is water and amine is there. Okay, this is the water, this hydrogen attached to the oxygen. So due to this del positive and this nitrogen having a extra lone pair, they can make a extra bond. So that bond is hydrogen bond. Here nitrogen's hydrogen and oxygen's lone pair. So they maybe can form the bond. So that bond is the hydrogen bond. Okay, so the condition for the hydrogen bond, the molecule must contain a highly electronegative atom linked with the hydrogen atom. Okay, so electronegative atoms when linked with the hydrogen atoms at and that types when the higher the electronegative, greater the polarization of that molecule takes place. So higher the electronegative atoms and hydrogens, more the polarization form, then pole forms, the pale pole forms. After that, another molecule of the same or different compound may form the bond with that deficient hydrogen, and that rich oxygen can make a form with another deficient hydrogen. So that extra bond is the hydrogen. Okay. The size of electronegative atom should be small. Okay, it should be small, but because it is the electrostatic attraction, for that easily for that the size should be small. Okay, so smaller the size of electronegative atom, greater the electrostatic attractions. Okay, so for the electrostatic attractions, positive negative attractions, for that positive negative attraction, size should be small. When the size is the small, they can easily can attract, electrostatic attraction can take place. So that electronegative atom should have the non-bonding electrons, means lone pair it is the must. So generally oxygen, fluorine and nitrogen atom shows the hydrogen bonding. Okay, here this is the chlorine and this is other water molecules are there. So they make a hydrogen bonding. Chlorine having a lone pairs, so they're making the hydrogen bond with this hydrogen. But this hydrogen should be attached with oxygen, this hydrogen attached with oxygen, this hydrogen attached with oxygen. So these types of conditions is must for that hydrogen bond. Okay, so types of hydrogen bonding, there are also types of hydrogen bondings. So first one, intermolecular hydrogen bonding. So this exists between the two or more molecule of the same or different compound. Okay, so the hydrogen intermolecular hydrogen bonding means that molecule, the two molecules should be different. Compound should be same or maybe different, but molecule should be two molecules. Okay, here two nitrogens, two ammonia is there. Okay, so this one another ammonia, this one another ammonia. So two ammonia are there. Okay, this ammonia or ammonia water, like that. Okay, there are also two types accordingly, intermolecular hydrogen bonding. So the homo intermolecular hydrogen bonding. Okay, so homo means same, ammonia, two molecules of ammonia, two molecules of water, two molecules of hydrogen chloride. Okay, so these types of bonding is the hydrogen bonding, and that is the homo internuclear hydrogen bonding. It is also termed as self association. Okay, so self association is happen there. So it refers to the associations of two or more identical molecules. Identicals in the form of these two molecules are the same. There is a hydrogen bonding will happen. Okay, so example association in alcohol, two molecule of alcohol, ethanol, methanol. So that types of association with water molecule, two molecule of water and their hydrogen bonding. Ammonia, two molecule of ammonia, particularly given example HF is there. So this type of nitrogen electronegative, and this make a hydrogen bonding with another hydrogen. This nitrogen make a hydrogen bonding with another hydrogen, but that hydrogen should be attached with the heteroatom. These types of nitrogen more electronegative atom. Okay. So here this is the example is given. This is the water molecule. So O negative, H positive. That O negative make a bond with another H positive. That O negative bond with another H positive. That O negative with another H positive. Okay. Here hydrogen bonding in water molecule, and this H plus make a hydrogen bond with another O negative. Okay. So there is somewhat the here. So another one more is the heteronuclear, means one of the water molecule, one of the ammonia, but two molecules should be, molecule two should be two. It should be same or different. Same as when it is the same, then we can say homo. Then this molecule are the different, one ammonia, one water, then we can say hetero. Okay, hetero intermolecular hydrogen bonding. So it involves the association of two different species. The species which donates the lone pairs of the electron is called the electron donor and hydrogen acceptor, while the other word is donate proton, the called as proton donor. Okay, here the ethanol is given. This is the black is there, black and this red OH. So that is the ethanol. So and this is the water. Okay, so ethanolic H make a hydrogen bonding with this oxygen of the water molecule, and here oxygen of ethanol make a hydrogen bonding with hydrogen of oxygen, another water molecule. Okay, so these types of bonding, the molecule is the different. Okay, molecules are two molecules, two more than two molecules. Okay, so that is bonding is ethanol and water bonding, and that is the intermolecular bonding. And here it is the hetero means one ethanol and one water. Okay, bonding like that. If it is in water water, then it is the homo intermolecular. Okay, is hetero means one of the ethanol, one of the water. Okay, so here one more example. Dimethyl ether, so etheric oxygen with bonding with water molecules hydrogen. So that is the hydrogen bonding, because this hydrogen attached with heteroatom, so it is the deficient hydrogen. So this rich oxygens and this deficient hydrogen make a extra bond, that is the hydrogen bond. So one more type is there, another type, that is the second type is intermolecular hydrogen bonding. Inter means it's within the molecule only. Molecule is only one, and hydrogen bonding in between the another active sites of that molecules. So that hydrogen bonding is intramolecular hydrogen bonding. Okay, so before that we will discuss the intermolecular hydrogen bonding causes, what exactly happened due to the intermolecular hydrogen bonding. Okay, so the intermolecular hydrogen bonding causes rise in melting and boiling point. Why melting and boiling point is rises here? Because there is, we want to break this extra electrostatic attractions, dipole attraction, electrostatic attraction. We have to break that. We have to break that. Then and then it can be melt, or then and then it can be boil. Okay, so for that we require extra energy. So for extra energy we require means, that is the increase in the rise the that particular molecules melting and boiling point. So we have to extra energy required to break the hydrogen bond. Okay, so in what's more, increase the solubility due to the solvation. Solubility is increased because water molecule easily bonded with that molecule. They can solvalysis is very much easy. Solvations is very much easy. Of the solid molecule is polar solvent by the hydrogen bonding. So it is the pole formation takes place easily. Solution takes place here. So thus alcohols, amines are soluble in waters. Okay. The second part of it is the intramolecular. We already discussed about that. The intramolecular hydrogen bonding. When hydrogen bonding takes place within a molecule is called the intramolecular hydrogen bonding. Within the molecule means molecule is the only one molecules, but they have two more active sites, two more functional groups. That particular molecule when it's attached, when is available, that time they should be possibility for the intramolecular hydrogen bonding. Okay, it takes place in the compound containing two groups, such that one group contain a H atom, hydrogen atom linkage with heteroatom, okay, linkage with electronegative atoms, and other group contain a highly electronegative atom linked to the lesser electronegative atom. Okay, so here example is there. This is the orthonitrophenol. This is the example of orthonitrophenol. Okay, this is the intramolecular hydrogen bonding. Both the donor and acceptor both are in the part of the same molecule. Okay, it is the only one molecule. Okay, so this hydrogens, oxygens attached with oxygen, so that's why this hydrogen is deficient, and this is the oxygen electronegative, and having a extra lone pair, they can bond with make bond. So that bond is intramolecular hydrogen bond. Okay, so there is one more example, salicylic acid. So this OH is this hydrogen attached with oxygen atom with sigma bond. Due to the inductive effect, this hydrogen is del positive, is deficient in center. So it is deficient, this plus pole, and this oxygen having a lone pair, this is the minus pole. So this pole dipole attraction takes place, and this types of hydrogen bonding formation takes place. But this both the active sites, this both the functional group, this both the things are in the same molecule. This molecule is only one, salicylic acid. Okay, this salicylic acid, only one molecule having a two sites, and they making the hydrogen bonding. So that is the intramolecular hydrogen bonding. Intra means within that particular molecule. Okay, so the bond is formed between the hydrogen atoms and one group with a more electronegative atoms of the other group. So intramolecular hydrogen bonding is involved in a compound like a orthonitrophenol and salicylic acid. We already discussed about that. Okay, so intramolecular hydrogen bonding causes, what they exactly cause, what effect of that. So we will discuss the intramolecular hydrogen bonding causes. The intramolecular hydrogen bonding prevent the association of molecule, because the bonding should be in extra, so there is the associations and causes the contractions of size, because hydrogen bonding, extra hydrogen bonding contraction in size of molecules and hence decrease its surface area. Surface area is decreases because the size is contraction. Consequently, intermolecular hydrogen bonding result in lowering their melting and boiling point. So size is less, okay, surface area is less, then melting and boiling point lowering because there is no chance of intermolecular hydrogen bonding. That's why no increasing is chance, just only the lowering the melting and boiling point due to the decrease in the surface area. Okay, it is decreases their solubility with increase with vapor pressures. Solubility is decreases because there is no ionizations, there is no any associations with another solvent or molecules takes place because bonding is within the molecule. So no question arises for the any outer bondings or any intermolecular bonding. Okay. So the intermolecular hydrogen bonding produce result opposite to that of intermolecular bonding. We already discussed. So intermolecular melting and boiling point increases hydrogen bonding, and intermolecular melting and boiling point decreases. So intermolecular associations is increases, in the intermolecular association solubility decreases. Okay. So the increase the acidic strength of the stabilization of the acidic ion by the intermolecular hydrogen bonding. Okay. This is the salicylic acid. So it can easily donate the proton. When it is donate the protons, at that time this anion, that carboxylic anion, may stabilize with the hydrogen bonding with adjacent OH group. So that is the one more factor. This the bonding, there is the intramolecular hydrogen bonding is possible at that acid group can strong acid with their another analogs. Okay, so the increase the acidic strain by stabilizations of acidic ion by the intramolecular hydrogen bonding. Thus salicylic acid is stronger than its isomer. Okay, salicylic acid means ortho hydroxy carboxylic benzoic acid. If there is para and meta is there, so at that with compare this one, this is the more acidic because when it loses the proton, is donate the protons, stability for that anion is possible due to the hydrogen bonding. Okay, it's engaged with that hydrogen, so it is the easily can donate the protons, it can easily donate the protons, so that acid is the stronger acid than other their isomers. Okay. So properties of hydrogen bonding, what is the properties of that? So hydrogen bond is the bond in which the hydrogen atom is held between the two electronegative atoms. Okay, so it's never involves the more than two atoms. Okay, it's only between the two atoms. So in the formation of hydrogen bond, electron pair is not share, is thus the differ from the covalent bond. It is not, there is not a sharing, there is only the stabilizing of that deficient center by the rich center. Only electrostatic attraction is there. Okay, there is no directly donation or covalent bond formation takes place. So hydrogen bond is not a covalent bond. Okay, the strength of this bond is very small because it is the just electrostatic attraction, just only dipole attraction only, that is stability. So there is no, it is not a strong bond, or strength of that bond is very much weak. Okay, so thus the strength of the hydrogen bonds depends upon the electronegativity of the atom is which hydrogen atom is attached with that covalent bond. Okay. So the typical hydrogen bond is linear. Regular hydrogen bonds exist a solid, or it is the intramolecular hydrogen bond. Okay, so hydrogen bonds involve the dipole attractions. Okay, so thank you very much. So now we will stop here. Hope you understand.